Hello everyone, welcome back to online lecture series on fluid mechanics and hydraulic machines. We are continuing our topic of dimensional and model analysis. In our previous lecture, we started with dimensionless numbers in which we completed the Reynolds number. So let's continue from there. So the next number is second. Froude's number, which is equal to Fe, that is equal to square root of inertia force to gravity force. That is equal to square root of Fi upon Fg is equal to square root of rho a v square divided by, we already have rho a v square as the inertia force, and in case of Fg, if we say Fg is equal to mg is equal to rho a L into G. Instead of m, we have written rho a L. So rho a L G. So this two will get cancelled. So we are left with V upon square root of L G. That is the Froude number. The third one is Euler's number. That is given by EU that is equal to square root of inertia force to pressure force. Is equal to square root of Fi upon Ft is equal to square root of rho a v square upon equal to V upon square root of P on rho. Now let's move forward with our fourth number, that is Weber's number. That is W E square root of inertia force surface tension force. Is equal to square root of Fi of Fs. So this is equal to square root of rho A V square divided by sigma into L. So instead of area we can put L square, that is rho L square V square on sigma L. So L will get cancelled and we will finally get V upon square root of sigma upon rho L. So let's copy this one into our main slides. Still we are left with one more number, that is fifth one, Mach number. Which is again given by square root of, so let me write it over here. M is equal to square root of inertia force to elastic force. Which is equal to rho P V square elastic forces Ka so E will get cancelled and we will get V divided by square root of K upon rho here, and K upon rho is nothing but speed of sound in the fluid. So M is equal to V upon C, where C is equal to square root of K upon rho is equal to speed of sound in fluid. So let's copy this code. Now we will move forward with our new topic. The topic is model laws. First model law is Reynolds model law. So these are the models which are based on Reynolds number, and this is applicable for pipe flow, and applicable for resistance experienced by submarines, airplanes, etc. Now in this case the Reynolds number will be same for models and prototypes. So in such case we can say, so here also one more thing, that this model law is holds good when the viscous forces are dominating in comparison with the other forces. So RE of model is equal to RE of prototype. So we can say rho m Vm Lm upon mu m is equal to rho p Vt LP upon mu P. So we can say rho P upon rho M into Vp upon Vm into Lp upon Lm divided by mu P upon mu M is equal to 1. So finally we can write down rho R VR LR upon mu R. So I am not writing down this in words, but rho R, L, VR, LR and mu R are scale ratios for density, velocity, length and dynamic viscosity respectively. Now let's move forward with our next model law. That is Froude's model law. Now this is applicable when the gravitational forces are predominant in the given physical phenomenon, and in this case also, similar to our previous theory, the Froude number between the model and prototype will be same. So this is applicable in the following cases: free surface flows, flow of jet, from nozzle or orifice, now the Froude number will be same, so Fe between model is equal to Fe of prototype. So here Vm divided by square root of Gm Lm is equal to Vp divided by square root of Gp L. So suppose both are model and prototype are at the same place, then gravity will be same. So Vm upon square root of Lm is equal to Vp upon square root of Lp. So we can say it implies that Vp upon Vm is equal to square root of Lp upon Lm is equal to square root of Lr. So that is the Froude's model law. Now let's move forward with the third model law. Over here. That is Euler's model law. Now this is applicable when pressure forces are predominating in the physical phenomenon. So we can say EU of model is equal to EU of prototype. So we can say that Vm divided by square root of Pm upon rho m is equal to Vp upon square root of P over P. Suppose both the fluid in both model and prototype is same, then density will be equal. So we can say that Vm upon square root of Pm is equal to Vp upon square root of P. Now the fourth law, that is Weber's model. So this is useful when the surface tension forces are dominating. So here WE of model is equal to WE of prototype. So we can say that Vm divided by square root of sigma m upon rho m into Lm is equal to Vp divided by square root of sigma p upon rho p into Lp. Now where this is applicable, this law is applicable for capillary rise in narrow passages. Capillary movement of water on soil. Third is capillary waves in channels. Now let's move forward to our fifth and last law, which is Mach model law. Obviously, this will be applicable when the elastic forces are dominating with Mach number being same. So Mach number of model and Mach number of prototype is same. So here we can say that Vm divided by square root of Km upon rho m is equal to Vp upon square root of Kt upon rho p, and this is applicable in case of flow of aeroplane and projectiles. Then we have aerodynamic testing. And water hammer problems. So these are the 5 model laws, and let's copy them into our main slide. Let's move forward to our last topic, that is classification of movements. So here we are having two types. First is undistorted models. That is, geometric similarity between model and prototype. So when there is a geometric similarity between model and prototype, the model is called undistorted model. That means the scale ratio for linear dimension between model and prototype is same, and the behavior of prototype can be easily predicted from the behavior of model in such case. Now second is distorted model. In which the model is not geometrically similar to prototype, so no geometric similarity. Between model and prototype. So scale ratios are different between model and prototype. Now two different scale ratios are used here. One is for horizontal scale ratio, one is for vertical dimensions, and second is for horizontal and second is for vertical dimensions. So two different scale ratios for horizontal and vertical dimensions. Now where this is applicable, distorted modeling is applicable in case of rivers, harbors and reservoirs, because here it is not possible to take geometric similarity. Suppose for example, if we take river and then horizontal and vertical dimensions are taken same, that is scale ratio is same, then in case of river the depth of water will be very small in such case. So there are some cases like in case of rivers and harbors or other reservoirs where it becomes necessary to use different scale ratios for different directions, and it becomes a distorted model. Now the scale ratio for distorted model. First is LR that is scale ratio for horizontal dimension. That is equal to LP upon LN is equal to BP upon BN. That is linear horizontal dimension for prototype and divided by linear horizontal dimension for model. Now the next is LR. E is equal to scale ratio for vertical dimension which is equal to HP upon HP, that is equal to linear vertical dimension for prototype divided by linear vertical dimension for model. So these are the two scale ratios in different dimensions. So that's all for classification of models. Let's copy this work into our main slides. So that is the end of today's lecture, end of this chapter, as well as end of this subject. Thank you for watching this video.